Continuing with the day one nature of the roots unit, as I talked about, we're going to talk about the discriminant. The discriminant is just what's underneath the radical for the quadratic formula. All right, if you take a look, I've highlighted it. It's b squared minus 4ac. Below here, you'll be able to see a few examples. The first one, if the discriminant, the b squared minus 4ac, is positive, you'll have two real roots. So there's a picture of it crossing the x-axis. If you take a look at where it says 0, so if the discriminant was equal to 0, as the example shows, it would have two of the same roots, or one root, where it crosses the x-axis at the vertex of the quadratic. And then if it's negative, as we just saw, you will have a parabola that does not cross the x-axis. So the next thing that we are going to be doing is we're going to take a look. Now here are our cases, and specifically the chart that we are going to be using throughout much of this chapter. All right, and obviously you have that in front of you. So we're going to start off, and here are some just cases, and I'll keep going back to them. We're going to go down to the bottom. This says, find the discriminant. Now you don't have the book pages, but I'm going to give you what the equations are. So for number 1, the equation is x squared minus 5x plus 6 is equal to 0. The second equation is c squared plus 2c minus 10 is equal to 0. And the third one is r squared, which equals 7r plus 5. And we're asked in the instructions for these to find the discriminant. That's it. So remember, our discriminant, and we're going to write it right here, is equal to, once again, what's underneath the radical, the quadratic formula. B squared minus 4ac. So that's all we're going to do. So looking at number 1, the first thing you want to do is you want to make sure it's in standard form, and it is. All right, the next thing we want to do is we want to find the discriminant. So the discriminant is equal to, looking up here, b squared. So my b value is negative 5. Making sure we are using parentheses. Minus 4 times a. Our a value is number in front of x squared, which is 1, times c. All right, so when we simplify that, again, you can use your calculator. Your discriminant is equal to 1. So that's our answer. So now, just from this, we can tell and look at our chart and tell what this is going to be, or this specific quadratic. So we've got to look at our cases. First of all, look at case 1. Is it 0 or positive or negative? Well, we know it's positive, so that means it's going to be real. All right, so we're going to write 2 real. Now we're going to look at case 2. Case 2 says, which is right here, is it 0 or non-zero? Well, 1 is obviously non-zero, so therefore it is unequal. So 2 real, unequal, which means, once again, not the same. And then we look at case 3. Is it a perfect square or is it a positive non-perfect square? Well, 1 is a perfect square, so because of that, it's rational. And then we just write roots. All right. Next thing we're going to do is we're going to take a look at number 2. Now, the first thing we need to do is make sure it's in standard form, and it is. All right, so we have our discriminant. So we're going to write discriminant is equal to, we're going to plug in. So we have b squared, so our b value is 2, minus 4 times a value is 1, times our c value, which is negative 10. So once again, you can use your calculator, make sure you use parentheses. But when we do this, 2 squared is 4. Negative 4 times 1 is negative 4 times negative 10 is 40. So basically we have 4 plus 40, which is 44. Now that's our answer for this. Now we're just going a little bit deeper and we're going to talk about what this exactly means. All right, so we take a look at our cases. We'll go up top. Case 1, is it 0 positive or is it negative? Well, 44 is positive, so therefore real. So we're going to go down here, we're going to write 2, real. Look at case 2 now. Is 44 0 or non-zero? Well, obviously 44 is non-zero. So it's unequal. And then we look at case 3. Is 44 a perfect square? No, it is not. If you plug in your calculator, you get a decimal answer. So therefore, it is a non-perfect square. So it is positive non-perfect square, so it's irrational. Number 3 you're going to do on your own is part of your homework. But the first thing we want to do is you want to put this in standard form. So I'm going to subtract 7r and subtract 5. So we have r squared minus 7r minus 5 is equal to 0. So you're going to be doing that one for your homework for tonight. We're going to continue over to our next page. For our next page, we're going to state the nature of our roots. All right, so you're going to be given a couple questions and we have to decide using our table from the previous page. So to state the nature of the roots, I'm going to write down these examples. So for 7, they're telling us the discriminant is equal to 49. For number 10, they're telling us the discriminant is equal to negative 4. For number 11, they're telling us the discriminant is equal to 17. And I'm going to add one more. I'm just going to put this as example. We're going to say that the discriminant is equal to 0. Okay? So now, we have our discriminant, so we don't have to find the b squared minus 4ac. We are just going to find out and use our table to figure out what this is telling us. So if our discriminant is equal to 49, we know we have 2. Once again, we go back to the table. Because looking at case 1, 49, all right, is positive. We know it's real. We go back to our page. So we have 2 real. Now we ask ourselves 49. Is 49 case 2? 49 is non-zero, so therefore it is unequal. Then we look at case 3. Case 3, 49 is a perfect square, so therefore it's rational, which means it terminates, or it repeats, or it can be represented as a fraction. And roots. Next thing we're going to take a look at is number 10. So now we're telling us our discriminant is negative 4. If our discriminant is negative, we automatically can just write 2 imaginary roots. And once again, that comes from this previous page. Case 1, it's negative, so therefore it's imaginary. If it's imaginary, we can stop. I would like you to do example number 11. In this specific example here, when the discriminant is equal to 0. Describe the roots like we did here. This was our answer for this one, and this is our answer for number 7. The last type that we're going to do, all right, is going to be finding. We're going to combine both skills. We're going to find the discriminant, and then we're going to state what the roots are. All right, so I'm going to write down our examples here. So for number 22, we have x squared minus 7x plus 10 is equal to 0. Number 25 is 3y squared minus 7y is equal to 4. Number 26 is 9c squared minus 6c. And then number 30 is 25x squared plus 4 is equal to 0. And one more thing, I want to make sure that this is equal to, looking at 26, 9c squared is equal to 6c. So to start off with number 22, it's going to determine the nature of the roots without solving. So first thing we need to do is we need to find our discriminant. Our discriminant, again, is from the quadratic formula. We have b squared minus 4ac. So our b value is negative 7 squared minus 4 times our a value, which is in front of x squared, which is 1. Then we have our c value, which is 10. We're going to simplify that using our calculator. You can do it by hand, but check with your calculator to get 9. So the discriminant is equal to 9. Because the discriminant is equal to 9, we need to look at our table. Well, 9, flipping back, is real because it's a 0 or positive, it's not negative. Choice 2, 9 is either choice 0 or non-zero. It's non-zero, so it's unequal. And then in case 3, 9 is a perfect square, so it's rational. So our final answer for this one would be 2, real, unequal, rational. Roots. So that would be our entire answer for this first one. All right. We're going to take a look at number 25. So for 25, we're asked to do the exact same thing. Find the discriminant and then describe the nature of the roots. So we have our discriminant. And I wrote it once for this page, so I'm not going to write it again. You can. I know I have b squared, so negative 7 squared minus 4 times a. So our a value is 3 times c. Now, don't get confused with this. As we said before, we need to put this in standard form. So I have to subtract that 4. So you have 3y squared minus 7y minus 4 is equal to 0. So when you plug this in, it's a negative 4. Make sure you're careful with that. We're going to simplify. So we have negative 7 squared, which is 49. Negative 4 times 3 is negative 12. Negative 12 times negative 4 is a positive 48. We combine those, and we get our discriminant is equal to 97. So that's the first part of our answer. So now we have to describe what that means. So we look back to our table. Our table So we know 97 is positive, so therefore it's real. It is non-zero, so therefore it is unequal. And it is not a perfect square. It's positive, non-perfect square, so it's irrational. We're going to flip back. We're going to write our answer. So we have 2 real, unequal. Now, these are just bullets that I'm writing here to describe the roots. Irrational, roots. So this is our entire answer for number 25. You are going to do numbers 26 and 30 as part of your homework. Thank you.